when you're ready to start.
Okay, thank you. Good evening. First of all, I would like to correct a little bit. Plumbr has started as memory leak detection tool. Right now, we are discovering much more problems, starting with GC pauses, and more problems are to come. So it's more like performance monitoring tool. But yes, today I will speak about memory leaks, and I will show some slides, and then I will switch to code and live demonstration. If you have any questions, I hope Kon can facilitate and somehow direct them to me. So if you have any questions, just ask. I will try to answer them as best as I can. And if you have problems understanding my Estonian English, because, well, I am Russian, I live in Estonia, and now I'm speaking English, so it's 3 languages in my head, please interrupt me and I will try to explain myself. And okay, let me start with some slides. I hope you do see them. Oh, no, you don't. I have to pick screen share. Okay, start screen share. And now here are my slides. Do you see that?
Yes, we do. Yep.
Okay. Okay, as I have already told, Plumbr is a little startup, yet another startup from Estonia. We have started with solving memory leaks in Java applications, and now have added a little bit more problems into our toolbox. And memory leak. By our definition, memory leak is a very simple situation. It's a situation where there are some objects in your application, you're running JVM, when these objects are not going to be used by your application anymore. You have created those objects. You have created those objects, you have used them, but the application will not use them anymore. But garbage collector, whose job is to throw away those unused objects, by some reason he doesn't understand that these objects are not to be used anymore. So that creates a memory leak. And memory leak sometimes is, well, it's totally sometimes it is important for your application, sometimes it's not. It really depends how big that memory leak, how fast that is. So it's totally application specific, if it's a really problem or not. And the problem with memory leak detection is that from the outside, it's very hard to understand will your application use those objects or not. You can only understand that with time. You can really see, well, have your application used them in the past hour, day, week, or not? So that's the problem with memory leak detection. But today I will speak about one specific subclass of memory leaks, and that's Classloader. As you know, every class in Java application or in running JVM is loaded by Classloader. Classloader is just another class whose sole responsibility is to load other classes. And the problem with web applications and class loaders in web applications is that when you have your application server, Jetty, Tomcat, WebSphere, JBoss, and you have web application up and running, and then you undeploy that application, you stop the application. Application will not run anymore. But if one object, at least one object from that application was somehow left behind in that application server, and we will look today how that can happen, then this one object, every object in running JVM holds a reference to a class of that object, and every class holds a reference to Classloader that has loaded this class. And in Oracle JDK and in OpenJDK, every class loader has references to every and one class that has been loaded by that class loader. So we have that chain from one single object to class loader, and to every classes that has been loaded by this class loader. And so if after application and deploy, you have one object left behind, it still keeps all classes from your web application, all classes from your webinf lib folder, every third-party library that you have used in your application. All those classes are still in memory, and garbage collector cannot collect them, cannot throw them away, and cannot clean the memory. And so you have your permanent generation field filled with these classes, and you make a couple of undeploys or a couple of redeploys, then your permanent generation will fill up and you will get out of memory error permanent generation. Your application will crash. Or your whole JVM will crash with every application that there is. Sometimes in this point of my talk, some people ask, but well, why is this a problem? Permanent generation is already removed in Java 8. We will have metaspace, not permanent generation, so no problem. The thing is that metaspace or permanent generation removal hasn't solved class loader leaks in any way. You still have that references from object to class loader to every class, and you still have those classes loaded in memory. Okay, you now have much larger metaspace to fill, so your garbage has much more space to fill. Okay, that situation is similar to that. You don't care to clean your room, or to throw away your garbage bin, so you just, well, you move to larger house and you have much more space to litter. Okay, but well, that's still garbage. And the second point people made, well, I don't make redeploys. In the development, I don't redeploy. I use JRebel, for example. In production, we do not redeploy applications. We just restart the whole server. So that's not a problem. And essentially, you are almost right. So that's maybe not a problem. But one of the reasons I like to give this talk and like to talk about class loader leaks is this one. Because I believe that we as developers, we can do better. We can do better, we can write better code, we can keep our code cleaner, better, and we can fix those problems. We shouldn't close our eye that, well, we have some class loader leaks, so what, I will just make restart, no problem, problem solved. That's bad attitude, in my opinion. And one of the reasons I do this talk is to show people, to show library developers that we write right now sometimes shitty code. We write bugs in our application that we are aware of and we can fix them, but we are too lazy, or well, we think that's not important. And I think that's bad for us as the industry, as a group of professionals, we can say that. And the main problem with class loader leaks, why developers are so lazy to fix them, is because the majority of class loader leaks is not your fault. You, as an application developer, it's not your fault that your application has a class loader leak. The majority of class loader leaks is fault of some library developer. Some libraries, a third-party library that your application uses. And that is double-edged sword of our current notion of library or code reuse, modular development, open source library or project, because you want to use some functionality in your application. For example, data source, database connection pool, or something like that. Very common functionality that every one application around you use. So what do? You go to bin tray or My Event Central and you download some jar, you put that dependency in your Gradle build script, and you don't know what's inside. You do not know what bugs this library introduces into your code. I bet that that almost no one of us checks a library that you are going to add to your application. You don't check its issue tracker. You don't check what bugs does it have, and you don't check what transitive dependency is used by that library and what bugs those dependencies have. So we really have no idea what is running inside our application. And we have no idea what bugs are introduced into our application by that third-party library. And that's the main problem why Classloader leaks are so widespread and so, well, rarely to be fixed. And that was almost all from the slides. Now I will switch to demo. How this talk has been born from the first place is that about 2 years ago I was developing our client-facing web application. Plumbr, if you go to plumbr.eu, you will see our application. I was developing that a couple of years ago. That was a simple application, quite small. On that time, it had only 2 pages in web application. It's simple, crude application with some Hibernate, Spring, JSP, WebSockets running on JT8. Pretty simple application. And I was developing it. I was writing some code. I have developed a web component. Then I redeployed the application in my JT, and I have seen application crashed. Out of memory error permanent generation. Well, that was, I have taken that as a personal insight, because let me remind you, we are a company that developed a tool which finds memory leak. So I assume that we are smart developers. We know everything about memory leaks. In our application, there is no memory. Cannot be, shouldn't be, but right now, I was seeing out of memory from my own application. So I have taken that as a personal insult, and I have started digging. What's wrong? After 6 hours of digging, Googling, and investigating, I have found 4 Classloader leaks in small application with only 2 pages. 4 Classloader leaks in 2-page application. And the majority, well, all of them were, almost all of them, were from third-party libraries, and so this talk was born. And now I will switch to application. Have we any questions so far?
Any questions?
Is everything clear, understood?
Yeah, we're getting nods here. It's all. Yeah, you can keep going. Oh, wait, one question. Yeah.
If class is not being garbage collected, does it only also mean that any static fields that class are also garbage collected?
All right. So the question, did you hear that?
I haven't.
I'll just repeat the question for the recording as well. So the question is, if the class is not getting garbage collected, are any static fields in that class also not getting garbage collected?
Yes, if you have class held in memory, not garbage collected, then every static field and the value of every static field is left in the memory as well, yes.
Any other questions? Right, you carry on.
Okay, so I have small application, here it is. It's an ancient version of our web application. And what I'm going to do is I have application. It's run from my IDE, and I will gonna to redeploy that a couple of times. I will show how the point of this talk is to show to you Classloader leaks. So we have applications that have seven or 8 Classloader leaks. I will show how Plumbr finds them in that running application. But that's not product pitch. Well, not entirely. You can find all those Classloader leaks with other tools. You can make a redeploy, make a heap dump, open heap dump with Eclipse memory analyzer tools, for example, and find all those Classloader leaks there. With Plumbr is a little bit faster, so I will use Plumbr to demonstrate leaks. So I have one application here. This application is run within JVM with Plumbr attached, and this Plumbr communicates with the current version of our web application, and we will see reports, Classloader leak reports appearing here. So I have old Plumbr portal version running with new Plumbr agent communicated with new Plumbr portal and everything on my machine, that metaprogramming. Okay, so we have application up and running. Here it is, very simple application, couple of pages, nothing fancy. And now I will make a redeploy to that application. So now Jetty is going to redeploy their application, I hope, if demo effect will not happen. After redeploy happens, Plumbr, which runs inside this JVM application, will monitor if some classes has been left behind, if we have Classloader leaks, and if he finds something that was left behind, it will analyze why. So we have found one memory leak. Let's switch here and let's see what we have. So I will make that a little bit bigger. So we have, Plumbr has reported to us that we have some thread pool executor that we have forgotten to shut down. So we have application which uses some thread pool executor. Well, let me tell you, application doesn't use it. I know my application, I know that it doesn't use any thread pool executor. So what's going on? Why Plumbr thinks that I have some Classloader leaks which connected to some thread pool executor? If I now see what is running inside that thread pool, I see there are one thread running something, and here I see some com jolbox bonecp. Okay, I do know that my application uses bonecp connection pool. That is a database connection pool. So here is some leak created by bonecp library. We have, and after I went investigating what's wrong, I have discovered that I have, let me switch to presentation mode here. In my application, I have that simple servlet context listener which initialize data source, BONCP data source, when application starts. And the problem is that I have completely forgotten to close that connection pool after application has been undeployed. So I have created a resource, data source, connection pool. It has opened some connections to database because my application wants to use it. Now it's my responsibility as application developer to close that resource, to clean it up after application is undeployed. That's obvious. That's trivial hygiene. Everyone should do that. The problem is that even I, thinking about myself that I am a good developer, I have forgotten that. I have forgotten to call that simple method, close, from my context destroy for example method, and that's one of the problems. So in fact, you cannot be sure that you do that. Sometimes it happens. Sometimes it happens. We just forget to do that. So how to solve that? In this same servlet context listener on context destroy method, which is called by servlet container by MyJT when application is to be destroyed, I now call that data source close method. So now I will stop this the server and I will start it again, and we'll see if we have the problem fixed. And again, we have 1 minute if we have any questions in the meantime.
We're good, thank you. Okay.
So application is up and running again. I will make one more redeploy. And let's see if Plumbr finds something else. We have session running, we have alert history, so if demagods will be angry and my demo crash, then I have pre-generated reports already. Let's hope. Well, 2 leaks at once. Okay, let us see what's going on here. Okay, the leak in Classloader is being held by a thread named Google Common Base Internal Finalizer. What the heck? Again, I promise to you, my application doesn't use Google Common Base Internal Finalizer. I have no idea what is it. My application doesn't use it. So I have went googling Google. So I have went googling what Google Finalizer is, and that was one of the hardest problems. And after almost an hour, I have discovered that Google Common Base Internal Finalizer, it is part of Google Code library, which is used to clean up resources. And in my application, it is used by BONCP data source again to clean up stale database connections. If I create some database connections to database but have forgotten to clean them up, then this finalizer is a separate thread running and monitoring those connections, and it will clean them up. The problem is that library, Google Common whatever, it starts a thread and it does not provide any means to stop that thread. So in the essence, Google developers has created a time bomb for my application. Then provide me a library which silently on the background starts a thread and give you no means to kill that thread. It's guaranteed Classloader leak. What have I done wrong to Google? Why they punish me so? Well, yeah, some people think that Google is an evil company. Maybe they are right. I don't know. How to solve this particular problem? Well, there is no good solution because you cannot kill Finalizer thread by any public API. The only solution that I have found is to instruct BoneCP data source not to use that connection tracking mechanism, not to start the thread in the first place. So I will take responsibility of the connection handling or connection closing to myself, and data source, please do not start any threads to monitor that. So I just configure my data source not to start that separate thread. It's a workaround, but well, otherwise you have Classloader leaks with no means to fix it. Okay, that was another problem, and we have one more problem. And okay, leaking Classloader is being held by a thread named Abandoned Connection Cleanup Thread. Whoa, and this thread is currently running some MySQL JDBC. Okay, so I suppose it's somehow connected to MySQL driver that my application uses. And yes, in fact, after I went Googling again for abandoned connection cleanup thread, I have discovered a reported bug in MySQL Java Connect backtracking. That yes, MySQL driver, JDBC MySQL driver, starts a thread again to monitor stale database connections, and that thread is never killed. So if your application just takes a JDBC driver, you have a leak already. And how to solve this? Okay, in this particular case, I was lucky. I had a reported bug in the bug tracking system, and there was a solution. Part of the solution was to upgrade my JDBC driver to at least version 5.1.23. So I have to update it, and that's not enough. One more thing that I have to do is that I have to manually shut down this thread after my application is undeployed. And now let me ask you, how do you, as application developer, is supposed to know that? When you want to take a MySQL JDBC driver into your application, you go to MySQL Java Connector web page, you download the jar file, or you download it from JCenter, bin tray. You read some getting started guide, which says, okay, take the driver, put that into your web server or in your web bin flip folder, and you're good to go. And nobody, never, not one time, mentions that after you are done with that driver, please call some obscure abandoned connection cleanup thread shutdown method. Why are we doing that to ourselves, we as a developer? That's totally obscure piece of information that you have no chance to know unless and until you have stumbled upon Classloader leak and you went digging and you have found that bug report and bug tracking system, not in some fuck you class or manual page. No. Weird. Okay, so we have fixed 2 more problems. Now let's kill the application, let us start it again. And again, if we have some questions, now that is a good time to answer them.
No questions? Oh,
Probably I have one question. From library developer point of view, how would I know, like, what is the hooks? Like, my JDBC driver has no idea where your application will be deployed to. So it's WebSphere with its own lifecycle and class loaders that I believe they do have more than one, or just simple Jetty or Tomcat. So is it some kind of agreement between library applications and standard J2E specification or web server specification that we could use to provide those hooks to shut down our threads, like in those JDBC driver? I would probably think that those developers should be using those hooks, like when server shuts down, there will be some jndi registration that you can do to call this method. Is there any standard way to fix those problems from library perspective?
Very good question. Very good question. Thank you. If I'm not mistaken, in the recent Servlet 3 specification, there is at least, well, let me start from the beginning. The standard specification-based hook into web application lifecycle is, for example, servlet context listeners that I myself is using here. The problem is that you, as a library developer, in the past had no way to automatically hook into that, because the web application developer has to write that listener, has to configure his application either in web.xml file or via annotation that here is my listener, JT, please call this. And so it has to call your library-specific hook by hand. But if I'm not mistaken, I have not much experience yet with that. But in the latest 3, I'm not mistaken, Servlet 3 or some point specification, we can add those servlet context listeners programmatically. So there is a way, not standard and not widespread, but there is a way that you can, from your library, can get hold into servlet context if you can detect if you run inside some servlet context, then you can programmatically add listeners to this, and then you can hook into web application lifecycle and to clean your own resources. But I'm not aware that this is widespread behavior right now. So maybe the best or the simplest way for you is just to write clean and loud in your application, in your library manual or getting started guide, that after you have finished using my library, please call this and this hook. Because the problem is that many libraries even doesn't provide those hooks. That's the main problem. And if they do provide the hooks, they fail to document them. So good start, provide hooks and document them on your getting started guide or reference manual. That's the best answer I can give right now.
Related to that, Nikita, is there a static analysis tool like FindBugs or something that can track this for a library developer, so that they
I'm not aware of that. I don't know any. because in our experience, why we went into runtime monitoring, not static monitoring, is that memory leaks in general and Classloader leaks in particular, they are runtime behavior. That's runtime characteristic of the application. Because, well, we believe that it's not possible or feasible to track every code path in your application to detect if you clean up everything that you have put somewhere. Because, well, it's totally possible that you have published something into one part of your application, and totally different part of your application is responsible for cleaning this up. And how to detect those connections, I believe that's very hard. So runtime monitoring is much, much easier.
Yeah. Okay. And sorry, we had a comment.
What I was trying to comment is usually what happens that these drivers usually follow the jdi connector. I'm not sure whether this driver is used. For example, standard application servers or web servers. Will that behave will the application behave in the same way? Maybe it's because of the JD or sure.
Yeah. So did you hear that, Nikita?
No.
Repeat. So the comment was generally with, I'm going to paraphrase, so correct me here, but J2EE standard specifies ways to bring up drivers and release the resources. And could this just be that the driver developer hasn't considered a particular situation like Jetty or a particular kind of framework? And therefore, there's just an accident in a way that...
that's totally possible, in fact, because, well, in fact, in general, an advised way to bring, for example, JDBC drivers is to put them not into application class path, but into server class path. And then such problems will not happen. And you're totally correct that library developer cannot predict all situations where it will be used. My opinion is that you as a library developer does know that you start something, some threads, or you publish some resources somewhere, so you know how you influence outside world. And so you have to document those influences. I will start this and this thread, so maybe you have to shut them down. So you have to document that you have to speak to your users or your clients. I will change outside world in this and such a way. Please take that into account. That's my opinion.
Okay.
But in the meantime, we have yet another report. So let us see there, and that is one of my most interesting reports, or one of my favorites, because what we see here is that leaking Classloader is being held by MySQL JDBC driver class. This class is being held in the field name driver class in some Java SQL driver info, which is held in field element data in some vector. This is held in some static field write drivers in Java SQL driver manager. And that is my favorite report in this talk, because that is memory leak by design, by specification. Because JDBC specification, official JDBC specification states that if you write a driver, if you write a JDBC driver and want to claim that this driver specifies or satisfies the specification, then on class loading, on your driver, MySQL JDBC driver class loading, you have to register. You have to call register driver method on driver manager. What specification doesn't say and doesn't require and doesn't even mention in any way, in anywhere, that you have to unregister those drivers after application is done. Because driver manager on driver registration puts those classes, yes, in static field, and it does have a method unregistered driver, but it doesn't mention it anywhere in the specification. So if you just read specification and you implement your driver to the letter of that specification, you have created a memory leak to every of your clients. Class loader leak by specification. That's beautiful. So on how to solve that, in general case, we have a solution that you have to get that driver manager, get every driver, so you have to check if that driver has been loaded by your application and then unregister that. Complicated, magic, totally obscure piece of code. Fortunately, my data source is good enough to provide yet another solution, and it's this method. My data source, the BoneCP data source, has a configuration option which says deregister driver on close automatically. So whenever you call data source close, it will deregister those drivers for you automatically. Now, the million-dollar question: why this option is disabled by default? One little boolean which solves guarantee memory leak, and it's turned off by default. Why? That's exactly the point I'm trying to make. We as developers, we can do better. One little change and huge number of class loader leaks everywhere in the world is solved. Okay, solved it. Kill application, start it again. Any questions so far? We have 3 more leaks to go if we have time.
One question.
Maybe a reason why it's not on by default, if you put it to the Tomcat server class part, you would then unregister it, it would maybe cause other applications to fail.
Okay. So the comment, just for the recording, if you put it in the Tomcat class path, so presume the lib directory within Tomcat, and you unregistered it there, would it then affect all the applications running on the same container?
Okay, that may be an explanation, because yes, you're totally right. If that connection pool is configured not in your application but in Tomcat or in your application server, then yes, no, because you close application, you close data source, then only on your server shutdown, not your application undeploy. In case you use your data source in application, but you take your drivers from the server, then yeah, in this situation, that will break all other applications in Tomcat. Yes. So there are situations where this option should be turned off, but well, has it to be default value? I don't know. Okay, application up and running, redeploy. Okay, let Plumbr analyze. Any more questions?
One more, yeah.
What do you use to detect those memory leaks? Java Assist, eCell, something else?
So question was, what do you use to detect those memory leaks? Java Assist, bcell, what was there?
We use ISM library to instrument classes as they load it, and then we just monitor. Well, in this particular case, we just monitor web application lifecycle, and when application undeployed, we look either somebody who is holding on that application Classloader. And if yes, then why and for what reason? Okay, next report is threadlocal. That's a very good example of misuse of threadlocal. Java-lang threadlocal is very convenient functionality to use into multi-threaded or concurrent application. What almost every developer forgets about this is that threadlocal is essentially a custom scope for your values. You put something into threadlocal, so you put some value in that threadlocal in thread scope, which means that it's your responsibility to clean that value when you go out of that scope. In Java, you have method scope for local variables, and they are taken care of automatically by stack machine. You have object fields, yet another scope for your values, which is taken care by garbage collector. You have static fields, is yet another scope for your values, which again is more or less taken care of by garbage collector when it unloads the classes. But threadlocal scope is totally your responsibility, especially in the situation when you use application server or in any other environment where your threads are provided to you. You don't create threads usually in web server. You use threads provided by your Tomcat. When new HTTP request comes in, Tomcat spawns a new thread or uses its thread pool to handle that request. And if you put something in that thread locally, then it will stay there as long as that thread lives. And in Tomcat or JT web servers, thread pools can outlive your application by a wide margin. So if you put anything to threadlocal, you have to clean that up after you have used it. In this particular case, when I investigated why we do use threadlocal, I have discovered that in fact we do not need thread locals at all. So I just removed the use of thread local and I have switched to just method local variables, much simpler and no leak possible. So that one another case or example. Well, sometimes developers do forget about that. Thread locals are custom scope. It's your responsibility to clean values from that scope. And I believe we will have two more. Why two more? I don't remember. Okay, two more leaks. And again, it's being deployed. We have a little time for questions or comments. Up and running, redeploy. Now, what we will find next? Application is up. Plumbr looks into it, tries to decide what's going on. Is there some bad guy? Oh, there is. Okay, one more leak by design, and that's especially nasty. As we can see right now that we have some web app class loader which is being held by EU Plumbr stat log level, which is held in Java util logging level, known level, which is held in int2 levels static field in Java util logging level known level class, whatever it means. As it turns out, we have Java util logging framework built into JDK from, well, I don't remember, JDK 5, I believe. And it allows you to create custom log levels. So stat log level is just logging level specific to my application, because, well, I want to use some custom log level for finer tuning where my logging triggers go to files, to disk, etc. And so if you create a custom log level, then where was I? Then Java util logging framework will register that in some static map, and that Java util JDK class, which has a static field which holds references to your objects. And the funny thing is, or that cherry on the top of the cake, there is no way altogether to remove anything from that map. At all. No public or private API to remove anything. As long as you create new custom log level in your application, you have memory leak, without any official way to fix that. And if you now are going to say, I am mad, what not people will use custom log levels, that's some obscure functionality no one uses, then, well, unfortunately, you're wrong, because many JBoss products do use custom log levels. I have discovered this leak when supporting one of our clients who used JBoss, or some of JBoss libraries. I don't remember anymore. He uses JBoss library or JBoss server, and JBoss uses custom log levels. JBoss logging, if I'm not mistaken, uses custom log levels, which automatically leads you to Classloader leaks without any official or supported way to fix it. The only way to fix it is to use reflection to get hold on this non-level class, to get hold on this private field, and then remove your classes from that map. Reflection, static, dig into Java util logging inner classes. The only way to fix that leak. Or in my cases, I will make it simple for myself, and I will throw away that custom log level. I will not use it. That's it. That is fascinating. How we as developers, JBoss developers, JDK developers, we create those landmines everywhere. We shoot ourselves into foot, into head every time, every day. Why are we doing this? We can do better. Okay, and now let's start the application again, and we will hunt down the last leak in this application. I believe and I hope. That's a little bit depressing because, well, all those leaks, they are so trivial, and that we just don't think about it. We put something into static field and we don't provide any way to clean it. We start some thread and we don't think about how to stop that thread. We put something into threadlocal and forget about that. That's depressing. Okay, redeploy. Will we find anything? So I'm sorry for that sad and depressing talk. Okay, will we see the last leak?
So, Nikita, do you guys put a lot of bugs into the JDK bug tracker as a result of what you find with Plumbr?
Not many, because the next depressing thing about that is that the majority of bugs are already known and reported.
Mm-hmm.
But the fixes take a lot of time.
Yeah.
Well, that specific log level bug, if I'm not mistaken, Java util log level Classloader. Okay, I have no link at hand. One of those bugs in JDK that we have found was in fact reported 10 years ago, and it's still open. So majority of them are already reported, but while they are not fixed for one reason or another.
Yep.
I don't know why. Okay, and the last leak in this application has to do with jndi. Application on its start registers some or publishes the data source into jndi context, and it forgets to clean it. One more thing to remember, that if you publish something somewhere which is out of your application, out of your control, out of your domain, out of your scope, jndi context, I don't know, some static registry out there. If you put something somewhere, usually you have to clean that up as well. If that somewhere is outside of your application, it's not your class, you have to clean that. Again, very common case of Classloader leak. If you publish something into jndi, clean that up. Well, that's not very interesting, but well, I had to show that as well because it does happen from time to time. And that was the last leak in this tiny application from 2 web pages that we have found today. So 7 leaks in one small application. And I would like to finish with one more note, is that regarding those JDK bugs, I have said before that the fix usually takes a lot of time, so there are a lot of known bugs unfixed. But there are tons of bugs in JDK that are fixed. Regarding Classloader issues as well, In earlier versions of Java 6, for example, there are a lot more bugs in or Classloader leaks, and they got fixed. So if you can, please, pretty please, developers, do upgrade your JVM, do upgrade your Java on which you run your application. It will do better for you because Oracle JDK JVM teams are really great teams. They fix a lot of problems. In JDK 7 and 8, a lot of problems are fixed, a lot of performance issues are fixed. So please upgrade, make yourself a favor, and make us, tool vendors or tool developers, big favor by upgrading to newer Java versions, because it's pain in the ass to support earlier Java versions. Java 5 was big trouble for us. We have dropped that half a year ago only. And Java 6, which is now officially dead a year already, but it's still widespread use and we have many problems with that. So please, developers, make this world better, upgrade your Java installation. Do not use old Java. It is bugged and it creates a lot of sad pandas in developer world, in tool vendors. We don't like to be sad panda. So please upgrade your Java. But that was it from my demonstration. Where is my finishing slide? And thank you very much for your attention. If you have questions, I'm here for you. Thank you.
Thank you, Nikita. That's a very good talk. I'm going to put it out to the audience. Is there anybody who's got any questions?
As an application developer, in other words, like a library user, is this like a good idea to resolve these problems using the kernel classes, such as abundant class by schemer or something, like completely depending on the library?
Excuse me, it might be a better idea for you to come over near the microphone so that we don't lose half of it in translation when Ron has to repeat it. So, yeah.
I'm just going to switch off the screen share so you can see who you're talking to.
Yeah.
There you go.
Yeah, my question was, like if I'm using a particular library such as MySQL library, and I have to write code dependent on the library class, then it goes against the entire idea of programming with the interfaces. So wouldn't that be a better solution not to use that library altogether instead of solving the issue?
Well, that's your choice. I mean, if you have alternative for implementation, you want to use some functionality. If you have different alternative implementations for that functionality, that's your choice. And that, well, the existence of hooks or the existence of bugs is one of the arguments to choose one library or another. But from the practical point of view, I think that if you depend on some specific implementation in one specific, clearly distinguished point in your application, then that's okay. Because you have chosen that particular library for some reason, but sometimes you have to use implementation specific. So if you just abstract that or you hide that implementation specific code behind or in some very small part of your application, well, that's practical. You have to cope with that.
Yeah, I mean, my question was mostly to do with sometimes we need to move from one database to another database. So, for example, tomorrow I move to Oracle from MySQL, then my library, like driver classes, will change.
Yeah, and then you have to change that one little part of your application. Yes.
Yeah. Okay, cool. Thanks.
Oh, any other questions? Yeah.
Yeah, in the knowledge base of such libraries have
I can't hear you.
Okay, so the question, just to repeat it, is do you have a knowledge base of libraries that are leaking?
so, for example, you can have a graph button in Plumbr to send some information about this leaking.
Okay.
And for example, provide some solution to when I just run main on dependency tree, I have all libraries that I use and get all solutions to test all my resources.
Sure.
So something like this.
Yeah, so the suggestion was to have a tooling support so that if you, say for example in Maven or Gradle, you do a dependency tree list and you match those jars against a known database that, say, Plumbr would maintain of jars that have known Classloader leaks. Is there any, have you got any resource like that that maintains a shame list of jars that are naughty?
That's shameless. I like that. We don't have such a database so far, and well, the main reason I believe is it's very much work to maintain that database because there are some we have you have Tomcat which has that memory leak prevention listener, which tries to solve many of that Classloader leaks automatically for you. So they maintain some database in code. We have jndi, which is going to maintain the same database. There are some blogs on the web which maintain their database of Classloader leaks. So there are databases like that out there. We do not host or collect ourselves that because, well, we do not have enough resources to monitor every library, and when new version comes out, to recheck if they still have those old problems or if they have introduced new problems. So we have not, just because that's sheer amount of work. But it's very good, it's very interesting idea, in fact, to crowdsource that and to make the central database and to hook that into tooling chain. Well, that's very interesting idea. That certainly will make this world a lot better. But, well, we are a small startup. We don't have enough resources for that yet.
Good suggestion.
The more clients, the more money we have, the more resources we have.
So on that too, Nikita, would you suggest that people put something like Plumbr into their development workflow so that as they're writing software, they can see if they're introducing new leaks? And on that, is there anything? Do you guys feature any, I suppose, test fixtures or any means to invoke Plumbr, say while I'm writing my tests and executing my tests, so that I can see what leaks there are and get some insight into my app while the app is running?
Well, right now we still positioning or targeting Plumbr as a runtime monitoring tool. So if you talk about testing or something before production, then I can recommend to put Plumbr into your testing environment, in your staging server or test server.
Yep.
Then it will make good. To use Plumbr on your developer machine is sometimes feasible. For example, for Classloader leaks, you can use that on your developer machine. You start application, you redeploy that, and you see what's going on. For other performance problems that Plumbr monitors, like heap leak or GC poses, developer machine is usually too small and it has too little load. And right now we are runtime monitoring, so you cannot use Plumbr in some integration tests. That should be some acceptance tests on real JVM, running real application with real load from your users or your JMeter script or whatever.
Sure, sure. Okay, thank you. Is there a question?
Yeah, a question. So you mentioned several hours of trying to remediate the issues. Is there a plan to somewhat make that an easier effort?
So the question was, you mentioned earlier that there was up to several hours for finding and remediating those issues. So is there any plans to help improve that speed, that time?
We do provide we try to provide solutions for Classloader leaks. And if you find out if you find out that some particular Classloader leak is very widespread, for example, this one with driver registration. So if you find that some leak is very widespread from our client, then we do provide a solution for that leak. We do provide a solution right inside the report. Let me, for a moment, share my screen with you. Desktop, start, screen share. So if we look here for one particular report, then we have a solution for it. And we constantly monitor what leaks our clients find, and we add those solutions. So with time, we do hope to cover the majority of widespread leaks. And if that's one thing, and another is that if you are our paid client, and Plumbr finds some leak in your application, and you have no idea what is it, how to find it, then you contact us, and we will find the solution for you. That's a little problem.
Yep. Outsource the problem. Are there any further questions? No, I think that's it. All right. So I think we might end it there. I just want to say thank you to yourself, Nikita, and to Ivo for setting this up tonight. And once again, thank you for sponsoring the event.
Thank you for your audience. Thanks for your attention.
Yeah, very good. Thank you. Also, just quickly before I forget, we've just got a guy in the audience who helped make this happen. So, Laurie, if you just want to stand up for a sec, just to embarrass you here. Yeah, Laurie put us in touch with you guys. So, if it wasn't for him, we wouldn't have even had this event today. So, thanks to you as well.